Okay, so we're going to further the notion of using the function notation, and additionally we're going to look at some graphs to see if they're functions. Now, for some odd reason the graphs didn't save in the PDF format, so I'm going to have to check into that. But I drew some graphs on here that we can take a look at. So, first, we notice that there are two functions. That is, these right here, these are referring to the f function, and these down here, these are referring to the h function. Now, the f is defined to be this function here. The h is defined to be this function here. So we see f of 2, that's giving us reference to look at the f function here, and that's asking what is the function value when x equals 2. So once again, because we're plugging that in for the x that we see right here, we need to plug it in the x's over here. So this is going to be 3, plugging my 2 in, minus 4. 3 times 2 is 6, so we have 6 minus 4, which is negative 2. And that corresponds to the ordered pair 2, negative 2. So the answer is negative 2, but I'm just saying this corresponds to an ordered pair, which kind of takes us back to that notion of graphing. Second, we're asking what is f of negative 2. Now, where we see the x's over here, we're plugging in negative 2. So we have 3 times negative 2 minus 4. Multiplying that out, 3 times negative 2 is negative 6. Minus 4 gives us negative 10. So f of negative 2 equals negative 10. And really that means when x equals negative 2, the function value or the y value is negative 10. So on this last one we have f of a plus h. Well, what does that mean? It doesn't really matter what a plus h is. The rule of function notation says that we're going to plug that in to the x's where we see them right here. So this is 3a plus h minus 4. We could do some distribution here, I guess, if we wanted. 3 times a is 3a. That's an a. 3 times h is plus 3h. And then we have our minus 4. And that's just the answer right there. Now, the last thing here is we have h of 3, h of negative 4, and h of a plus h. So now, because this h is giving us reference to the h function, we're going to be plugging the x's into this new function right here. So h of 3, plugging it in. 3 squared minus 2 times 3. 3 squared is 9, so we have 9 minus 2 times 3 is 6. 9 minus 6 is 3. That is h of 3 is 3. H of negative 4, we're plugging that in for the x's right here. Now notice, we're plugging this in for the x's. Since x is being squared here, negative 4 is being squared there. Then negative 2 times negative 4, plugging it in right there. Negative 4 squared is 16. Negative 2 times negative 4 is plus 8. All told, this gives us 24. So h of negative 4 is 24. And then finally, this h of a plus h, we don't know what h of a plus h is. We don't even really know what a plus h is, but it doesn't mean that we can't plug it in for the x's here. So this is going to give us a plus h squared minus 2a plus h, and we're just going to leave it at that. There is a way that we could expand this out, but we'll get to that in a couple sections when we talk about polynomials. So now what we have left is this. We want to determine whether the graphs that we have here are in fact graphs of functions. So we can determine whether the graph of something is a function or not by determining whether it passes the vertical line test. So once again, what the vertical line test states is if we draw vertical lines and it touches the graph at most once, this is a function. So yes, this first graph we have is a function. Now notice on the second one, I can draw a line that doesn't touch more than once. In fact, I could draw a line that touches exactly once. But there is a line that we can draw, specifically this line right here, which touches the graph at more than one spot, which means that this x value here corresponds to this y, and this x value corresponds to that y. This is not a function, because it fails the vertical line test. This next one down here, well, looks to be touching exactly at one spot, so yes, this is a function. And then finally this one, which is pretty cool and a crude drawing at best. Clearly this is not passing the vertical line test, so no, this is not a function. So hopefully that makes sense. Just remember the rule of function notation is we're plugging these values in to the x's there. That tells us we're looking at the f. This right here tells us we're looking at the h. Plug that in for the x. And then we can determine whether the graph is a function by using the vertical line test. So, see you next time.